Welcome back, guys. Once again, Liberty, thank you very much for this opportunity. And guys, please go and follow the Tenfold education app. Okay, you can watch these shows live on your iPhone, on your Samsung, whatever, wherever you are. Okay, it doesn't matter where you are, you can still watch and stream the shows live. Now, we looked at local climate just before the ad break. So let's just quickly have a look at mid-latitude cyclones. Okay, now first of all, if you look at our diagram, they presented us with a synoptic chart. Okay, a synoptic weather map, a synoptic chart is showing us the weather. Now, first of all, how do I know that's being depicted on this synoptic chart as a mid-latitude cyclone? Very importantly, when you hear the term mid-latitude cyclones, grade 12, I want you to remember this. Think immediately. Cold front, warm front. Immediately. Okay. Tropical cyclones got no fronts whatsoever. When you hear the term mid-latitude cyclones, think of a cold front and a warm front. And if you look at the synoptic chart, it's been depicted on it. Okay. Now, if you look at it, there is the cold front. There you can see with the spikes. Okay. And attached to it is the warm front. Okay. Now, when we look at mid-latitude cyclones, right, what do we know? A cyclone is a low pressure system. As you can see, there's the low pressure system being indicated over here. Okay, beautiful low pressure system. What do we know about low pressure systems in the southern hemisphere? It's a clockwise circulation of air. Okay. Now, I'm going to add a little bit of detail on the synoptic chart. Now, first of all, the name mid-latitude, because it develops in the mid-latitudes. Now, if you think of latitudes, we start at the equator from 0 degrees and we work our way down all to 90 degrees. What's mid-latitude? Roughly 45 to 60 degrees. Am I correct? That's where we find mid-latitudes, because it exists between those latitudes. Okay. I just want to add over here, if you look at South Africa, we are situated on the 30-degree latitude line. Okay. So it happens well below the 30-degree latitude line. Now, before we're going to continue with the mid-latitude cyclone, pay attention to the following. Our three anticyclones. Okay, what's our anticyclones? The high pressure over here. Our anticyclone is a high pressure system. Okay, and the circulation of air is anti-clockwise. Now, remember, I'm just going to fill this in, anti-clockwise. Now, this high pressure system, it's quite stationary. Okay, there's three high pressure systems that dominate South Africa's climate. Because we are situated on the 30-degree latitude line, we are dominated by the subtropical high pressure belt. I'm quickly going to draw it for you just to make it sense for you. Okay, now, when we look at global air circulation, we got a low pressure belt over here, we got a subtropical high pressure belt, subpolar low pressure, and polar high pressure. Okay, where the equator is, we have the equatorial low pressure belt. We are situated on that 30-degree latitude line, and we are dominated by the high pressure belt. Okay. Now, the reason why I mentioned it's quite stationary is because we are situated on the 30-degree latitude line. Now, when we look at this high pressure over here, this high pressure in the Atlantic Ocean is known as the South Atlantic high pressure system. Okay. Now, if you move over to the East Coast, what do we have here? Another high pressure system. And this high pressure system is the reason we experience good rain, as you can see on the east coast of southern Africa, because it's known as the South Indian high pressure system. Okay, remember, okay, let's just get this correct. Low pressure is air rising. Air can rise in two different ways. First of all, extremely warm conditions. Okay, what does air do when it's warm? It rises. Okay, leads to cloud formation. Or another way how air can form is when the air is being forced to rise. Now, what can cause air to be forced? What can force air to rise? Simple, cold air. Now, when cold air and warm air collide, what's going to happen? The cold air is going to wedge underneath the warm air and it's going to force it upwards. Okay, very important. Now, that's the situation that we're dealing with mid-latitude cyclones. So, we have our South Atlantic high pressure situated over there. We have our South Indian high pressure situated over there. And over the interior, in winter, we have this, the Kalahari high pressure system. Okay, Kalahari high pressure system. Okay, but what we want to concentrate on, we want to go and have a look at this mid-latitude cyclones. Now, first of all, like I've mentioned to you before, when you see the two fronts, you know immediately it's a mid-latitude cyclone. Okay, going back to our diagram. Now, as you can see, how does this mid-latitude cyclone move? It moves from west to east. The simple reason why, because it moves in the westerlies. Okay. Now, what's basically tried to happen over here, grade 12s? This cold front tries to catch up with the warm front. It's like cops and robbers. Okay. This cold front tries to catch up with the warm front. Remember, a front separates two different masses of air. Okay. It's like a brick wall. On the one side, we have warm air, and the other side, we have cold air. Okay. That's what the front does. Now, if you look at this diagram, they even gave us the temperature behind the cold front. The air behind the cold front is very cold. Okay. The air behind the warm front is warm. The air in front of the warm front is cold. Okay, this is all cold air, as you can see. They even mentioned very cold conditions over there. So if I can depict this synoptic chart on a cross section, just want to use a different color pen. We got our surface over here, and what's basically happening now in South Africa, we see the following. We see a very blue, unfortunately you can't see it clearly. Let me just wipe this off. Okay. My cold front is going to be represented by this yellow pen. Okay. This is the cold air coming in. This is a symbol for a cold front. Okay. And this is our warm front from a cross-sectional point of view. Pay notice the difference in the gradient. Steep gradient, gentle gradient. Now, what did I say? A front is the leading edge of the cold air. So the air behind the cold front is going to be cold. The warm front, okay. The warm front is the leading edge of warm air. So this is going to be warm air. Okay. What's the air in front of the warm front? Let's just go back to our diagram. I've mentioned it. It's going to be cold. Now remember, this whole system moves from west to east. Like I've mentioned to you, it's like cops and robbers. This cold front over here tries to catch up with the warm front. So what happens? I've mentioned to you there's only two ways that air can rise. When we experience very warm conditions or when the air is being forced to rise. Okay. In this case, the air is being forced to rise by cold air. And what does this cold air do? It forces the warm air to rise. This warm air rise. It cools, condenses clouds, cumulonimbus clouds, and it rains. Just want to write there, cumulus nimbus. Nimbus means rain. Okay, cumulonimbus clouds. And we experience rain where the cold front meets the warm air or forces the warm air to rise. Now what happens at the warm front? Pay attention. I'm just going to put the warm front here in brackets. Okay, just underline it, circle it. We don't experience the warm front conditions in South Africa because it happens just below South Africa. It happens too far down south. Okay. Now, if you look at our diagram over here, synoptic, you can see that it's only the cold front that we experience in Southern Africa. We really experience the warm front. It happens just below Southern Africa. It's too far down. Okay. So, but the rain that's being experienced at the warm front is nimbus stratus. It's gentle rain. The simple reason, look at the pressure gradient. It's not as steep as where the cold front meets up with the warm air. So it's not being forced to rise. It just slides over the cold air that's in front of it. And we experience nimbus stratus type of clouds with soft rainfall. Okay. Now let's just quickly look at the questions that's being asked. Name the weather system responsible for the severe weather changes stated in the synoptic chart. Okay, I just want to clean my synoptic charts again. Okay, and we have identified it. It's a mid-latitude cyclone. So that's the correct answer over there. Okay. Remember, there is a low pressure system. You can see it's a mid-latitude cyclone. Okay, it's a low pressure system moving in a, you can see it in a clockwise direction. Now, give a reason for the easterly direction of the movement of this weather system. I've explained to you it moves from west to east because it moves in the westerlies. Now, I've just drawn up the global circulation of air, and I'll quickly explain it to you. Okay, now what do we know when we look at wind? What is wind? It's when air moves from a high pressure to a low pressure. It's known as wind. Okay, let's quickly go back to our global circulation of air. Now, we established that that's a low pressure, it's the equatorial low pressure, high pressure, subtropical high pressure. This is going to be the subpolar low pressure. And we have over here at the bottom the polar high pressure belt. Now remember, what did we say? Air moves from a high pressure to a low pressure. So it moves from, I just want to use a different color pen that we can use that we can all see clearly. Let's just use red. Okay, the air moves from the high pressure to the low pressure. Air moves from the high pressure to the low pressure. Air moves from the high pressure to the low pressure. Let me just draw it over. There's the equatorial low pressure. There's the subtropical high pressure. There's the subpolar low pressure. There's the polar high pressure. So we established that air moves from a, I'm just going to write there, 90 degrees, 60 degrees latitude, 30 degrees latitude, 0 degrees latitude. We established that air moves from a high pressure to a low pressure. High pressure to a low pressure, high pressure to a low pressure. Am I correct? Okay, that's known as wind. But now we need to revise. We talked about this in we learned this in grade 11. Does air move in a straight line? Definitely not. What does the Earth do around its own axis? Okay, there's a deflection taking place. Okay, remember that deflection. It's known as Coriolis force. Okay, deflection of wind because of the rotation of Earth around its own axis. That's known as Coriolis force. Now, if you stand with your back against the wind in the southern hemisphere, the Coriolis force will deflect to your left. Okay. If you stand with your back against the wind in the northern hemisphere, it will deflect to the right. Now, what happens? The air deflects to the left because of Coriolis force. The air deflects to the left because of the Coriolis force. The air deflects to the left. So in this case, the air moves into that direction. Moves into that direction and that direction. Now, these are known as your trade winds, and these, because it's known, the air being deflected from the subtropical high to the equatorial low is known as the tropical easterlies. The air moves from the subtropical high pressure to the subpolar low pressure and is known as the westerlies. Remember, wind is named from the direction it's coming from, very importantly. Okay, as you can see, these winds, it looks like they're moving, blowing west, but where they're coming from? They're coming from the east, the westerlies. Same goes from here, from the polar 90 high pressure belt. Air moves from the high pressure to the low pressure, and it's known as the polar easterlies. Okay, hopefully all of you know this because it was grade 11 work. Very important global circulation. Now, the wind belt that this mid-latitude cyclone moves is in the westerly wind belt. Okay, so we can write it down there, give a reason for the easterly direction of the movement of the weather system. I've just mentioned to you, wind is named from the direction it's coming from. So it comes from the westerly wind belt. Just want to use a different color pen. Okay. Next question. Explain why low temperatures are recorded at A. Now, as you can see, the simple reason in A, look at that low temperatures, 2 degrees Celsius. They even mentioned very cold air. Okay, the simple reason, if we go to our cross-sectional point of view, this cold air has moved from west to east, has displaced all the warm air, and what do we have left? It rained, and it's only cold air, sinking air that's left. Okay. Now explain why low temperatures are recorded at A. We can mention that the cold front displaced all of the warm air. And only cold air is left on the surface. Okay. Now, if we look at question 1.3.4, discuss 2 weather conditions associated with the passage of cold fronts. Okay. Now, when we talk about weather conditions, I want you to keep in mind, think of your weather station models. Okay. When we talk about weather station models, I'm just quickly going to draw one here. You've done it in grade 10. Weather conditions with, if you look at the weather station model, you got your cloud cover, right? You got your wind direction, you got your wind speed, you got your temperature, and you got your dew point temperature. And you have a symbol for the type of precipitation. Okay. Now, I've basically used a weather station. I'll explain it to you. The question is discuss 2 weather conditions associated with the passage of a cold front. Now, 2 weather conditions, we experience rain because the cold front, what does it do? It forces the warm air to rise. It cools, condenses clouds. Okay. Obviously, we experience rain, we experience strong winds. Now, as you can see, weather conditions, we're probably going to have 8/8 cloud cover, completely overcast. We're going to have thunderstorm activity, we're going to have low temperatures, and we're going to have a wind blowing in a northeasterly direction because it's backing, because it's turning, and we got strong wind speeds up to 25 knots. Okay. So that's temperature, that's dew point, that's precipitation, that's cloud cover expressed in octas, that's wind direction, and this is wind speed. Okay, so any of those can be weather conditions associated with the passage of the cold front. So we can just mention rain, and we can mention cold temperatures. Okay, provide evidence from the synoptic weather map as to why such severe weather conditions were forecast. Okay, simple reason for it. Why? You look at the cold temperatures, it's evidence from the synoptic chart, and you have your mid-latitude cyclone showing you the cold front moving from west to east. Okay, fantastic. So that's mid-latitude cyclones. Now, our next question that we're going to discuss is Bergwinds. Quickly take a minute break, just grab a glass of water. See you guys in a couple of seconds.